Hi, in this video I would like to continue solving the calculus test provided by the MIT online open course. In problem 4, they're asking to draw the graph of the derivative of the function y equal to f of x, which is given by this sketch. So by looking here in this graph, it can be noticed that these two curves are part of a circle of radius less than 3. All right, and so we have piece number 1, piece number 2, and then it has this piece number 3, which is a linear function and can be easily found, which has the expression y equal to mx plus b, and b is the y-intercept. The y-intercept is 0, and the slope, by taking 2 points, it's clear that the slope is minus 1. You can easily calculate the slope here by taking 2 points, y2 minus y1 over x2 minus x1, and the points are 0, 0, and 1 minus 1. So this will be minus 1 minus 0 over 1 minus 0, which is equal to minus 1. And b is just equal to 0. So this curve has the expression y equal to minus x. Now, this circle, suppose this circle has a radius given by capital R. So we know that the full circle can be expressed as x squared plus y squared equal to r squared, because it's centered around the origin. And solving for y, so we get y squared equal to r squared minus x squared. Then if you take the square root on both sides, you don't forget the plus minus, because it has two solutions. Square root of r squared minus x squared. So the positive solution corresponds to 1, because it's above the y-axis. So the one above the y-axis has the positive solution, and the one below the y-axis has the negative solution. So it's clear now we can express f of x as a piecewise function given by the following expression. So we can say that f of x is equal to, open a curly bracket. So first of all, it's the first positive. So you start from the left to the right. So first we consider this component. And so it's root r squared minus x squared for x between this value. Let's call it, it's not important to know the exact value for now, but let's call it minus r. So it's minus r less than equal to x less than or equal to minus 2. and then it's switched to this function, which is the linear function. So it's minus x for minus 2 less than equal to x less than 2, and then simply this component, which is minus root r squared minus x squared for 2 less than equal to x less than r, and finally 0 otherwise. So if you take the derivative, f prime of x, this is simply equal, you can use the chain rule here to get the answer of minus x over root r squared minus x squared for minus r less than x less than minus 2, and then minus 1 for minus 2 less than x less than 2, and then x over root r squared minus x squared for 2 less than x less than r, and finally 0 otherwise. So how do we sketch that? So between minus 2 and 2 is minus 1. So I'll make this a little bit bolder. And then here we notice that if you sketch, so there is a vertical asymptote and also there's a vertical asymptote at r, and then it's clear that when you approach the value of minus r, you approach this edge, the value goes up to infinity, and then when you reach the value minus 2, all right, you hit this value, and there is a jump. It's clear that there is a jump here, and this jump it means that the derivative at this point is undefined, which is clear from the fact that we have an edge. And remember, for at edges the derivative is undefined, and this is why we have this jump. Same thing here. The shape looks like something like that, and then it reaches 2 and stop. There is also a jump. Because of the edge here. So that's how the derivative looks like. Now let's solve problem 5. You are given a function, piecewise function, for 2 intervals, x less than 1. It's a linear function, ax plus b. x greater than or equal to 1. It's a polynomial of degree 4. The question is, find all the values a and b such that the function is differentiable. So what are the conditions for a function to be differentiable? It has to be continuous at every point. So a function is differentiable if f of x is continuous and smooth function for all values of x. So let's look at this carefully. If you take the derivative of this function is equal to what? Equal to a. And the derivative of this function is equal to 4x cubed plus 1. So that's basically the derivative. So this is the derivative for each piece, and then the derivative must be equal. So the derivative of this function f at 1 from the left must equal to the derivative of the same function f at 1 from the right. So there is no gap. The gap is closed. If this is not the case, then there is a gap, which means that the function is not smooth or the function may not be continuous. So using this condition, we can find the value a. So from 1 from the left, so this is 1 from the left, and this is 1 from the right. So 1 from the left, you plug in 1 here, and the function is just equal to a. So a equal f prime, the derivative at 1 from the right, which when approaches 1 from the right, is just 4 1 cube plus 1. So in this case, a equal to 4 plus 1, which is 5. So now we were able to find the value a. Now how to find the value b? To find b, we said that the function f must be continuous, which means that the limit of f from the right should equal to the limit of f from the left at 1. So the limit of f at 1 from the right must equal to the limit of f at 1 from the left. So to find b, we use the fact that the limit of f of x when x approaches 1 from the left must equal to the limit of f of x when x approaches 1 from the right. So f of x, the limit when f of x approaches 1 from the left, it has the form ax plus b, but a is equal to 5. So this will be equal to the limit as x approaches 1 from the left of 5x plus b equal to the limit as x approaches 1 from the right of the function x to the 4 plus x plus 1. So substituting, direct substitution of 1, that will be 5 plus b equal to, plug in 1 here, will be 1 to the 4 plus 1 plus 1, which is equal to 3. So b is equal to 3 minus 5, which is minus 2. And that's it. We found a and we found b. That makes the function differentiable. Now, problem 6, we're asked to evaluate these limits by relating them to a derivative. So what does that mean? Remember that the definition of the derivative, f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. So the first step to solve this problem is to switch these values to h, and x, make it s, change of variable. So this will be equal to the limit as h approaches 0, 1 plus 2h to the power of 10 minus 1 divided by h. So one way to think about this problem is to try to say that if you let f of x equal to 1 plus 2x to the power of 10, then you would notice that we are evaluating the derivative. So this will be the derivative of the function f at 0. So you would notice that f prime of 0 is equal to the limit as h approaches 0, f of 0 plus h minus f of 0 divided by h. And this is equal to the limit. So this is just h plus 0 is just h. So the limit as h approaches 0, f of h minus f of 0 divided by h. And if you look here, f of h is simply 1 plus 2h to the power of 10, and f of 0 is equal to 1. So this is the original limit. So in this case, we need to find the derivative of this function and then evaluate it at 0. So f prime of 0, f prime of x is equal to, using the chain rule, this is just 2 times 10 times 1 plus 2x to the power of 9, which is equal to 20. 1 plus 2x to the power of 9, and then evaluate this at 0, will give us f prime of 0 equal to 20. So this limit is equal to 20. The second question, evaluate this limit. Use a similar approach. So here we will follow the same approach. First, let's replace each variable x by h to make it consistent with what we know from the derivative definition. So this will be the limit as h approaches 0, square root of cosine h minus 1 divided by h. Similarly, think about it. It's clear that this can be written as the derivative of a function f evaluated at 0 as well. So, and what is that function? This function could be f of x. We can try cosine of x, right? Because f of 0 is equal to cosine 0, which is equal to 1, and f of 0 plus h is simply cosine 0 plus h, which is cosine h. So because of the square root, this should be the square root, and square root of 1 is equal to 1, the square root of cosine h. So it's clear now that this option work out. So let me just minimize this. So in this case, we need to calculate the derivative of this function. Using the chain rule. So using the chain rule, this can be written as the derivative of the inside, which is minus sine x, divided by 2 times the square root of the inside, which is cosine of x. And the value of the derivative at 0 is minus sine of 0 divided by 2 root cosine 0, which is 1, and that's simply equal to 0 because sine of 0 is equal to 0. So this limit is equal to 0. Finally, derive the formula d by dx a to the x equal to m of a times a of x, a to the power of x, directly from the derivative, from the definition of the derivative, and identify m of a as a limit. So derive this formula. So let's see, the derivative d by dx of a to the power of x is defined as the limit. So if this is the function f of x, then we have the definition limit as h approaches 0, f of x plus h minus f of x divided by h. So this is equal to the limit as h approaches 0, and we have a to the power of x plus h minus a to the power of x divided by h. So we can continue this limit by expressing using the property of exponentials. So this is a to the power of x times a to the power of h. We can separate the power minus a to the power of x divided by h. Now notice that we have a common factor here. Okay, that is an expression of x only, no h, which means that it behaves like a constant with respect to the variable h. So basically I can take it outside of the limit times the limit as h approaches 0, a to the h minus 1 divided by h. So this basically represents the function m of a. So as you can see here, when you substitute h, this will be a function of a only. So this is defined as the function m a. So that's the limit that they're looking for. And that's it. Let's conclude the whole exam, and I'm hoping to solve another one in the next videos.